Hello everyone, we have a very interesting question here. We are to calculate the area of the circle. We have the length of this chord to be 24 centimeters. The length of this line is 18√3 centimeters, while this is 30 centimeters. This angle has its sides to be x, and similarly this also has its sides to be x. That means they are congruent. So how can we solve this? It is actually simple. The first thing we're going to do, we're going to draw a line perpendicular to this chord AC from this point B down here to chord AD. The length of this chord AC is 18√3 centimeters and that of this chord AD is 30 centimeters. Let's write them out here because today there is no room for ambiguity. Let's label this point P. Now look at this triangle. It is a right angle triangle. Based on the rule that the summation of angles in a triangle is 180 degrees, since this is 90 degrees and this is x, this must be 180 degrees minus 90 degrees minus x. 180 minus 90 is 90, so it is 90 degrees minus x. The same goes for this triangle here. Since this is 90 degrees and this is x, this must also be 90 degrees minus x. Now look at this triangle ABP. Since this angle and this angle are congruent, the triangle is an isosceles triangle. The side facing the congruent angles we know are equal in length. That is, this side and this side are equal. So since this is 24 centimeters, this must also be 24 centimeters. This line bisects this angle of H. That is, it is an angle bisector of the isosceles triangle ABP. The angle bisector of an isosceles triangle we know is also its median. That is, it bisects the sides opposite to the bisected angles, which is this side here. Therefore, this part and this part are congruent. Let's assume their lengths to be m each. The next thing we are going to do, you come here, draw a chord BC, and here a line that connects this point C and this point P. Look at the quadrilateral ABCP. This diagonal AC bisects this diagonal PP. It also bisects this angle here, BAP. And we have two adjacent sides of the quadrilateral, that is this side AP and this side AB, to be equal. These are the properties of a kite, meaning this quadrilateral ABCP is a kite-shaped quadrilateral. Therefore, this side and this side are also equal in length. Let's assume their length to be n each. We know the long diagonal of a kite, which is this line AC, bisects the two angles it touches. So just as it bisects this angle, it will also bisect this angle. That is, this and this angle are congruent. Let's assume their sizes to be y each. This triangle BCP, we know because of this angle and this congruent sides, is an isosceles triangle. The congruent sides are opposite to the base angles, which are this and this. We know the base angles are congruent, so if we assume the sides of this angle to be z, this must also be z. Now if we look at this angle 90 degrees minus x, this angle z and this angle, let's say theta, they are aligned on the same straight line. The angle on a straight line is 180 degrees. That is, the sum of this theta, this z, and this 90 degrees minus x is 180 degrees. So theta plus z plus 90 degrees minus x equal to 180 degrees. We take z plus 90 degrees and minus x to the right hand side of the equation. So theta equal to 180 degrees minus z minus 90 degrees plus x. This 180 degrees minus this 90 degrees is 90 degrees. So theta equal to 90 degrees minus z plus x. We keep it aside for now. Come here, draw another chord from this point C to this point D. Label this angle H. Now look at the quadrilateral ABCD. All its vertices are aligned on the circumference. That is, it is a cyclic quadrilateral. There is a property of a cyclic quadrilateral the opposite angles are supplementary, meaning opposite angles must sum up to 180 degrees. So the sum of this angle H and this angle ABC, which is divided into this 90 degrees minus x and this z, must be 180 degrees. So H plus 90 degrees minus x plus z equal to 180 degrees. Take 90 degrees minus x plus z to the right hand side of the equation. So H equal to 180 minus 90 plus x minus z. 180 minus 90 is 90. So H equal to 90 degrees plus x minus z, which is also 90 degrees minus z plus x. We have here that theta also equal to 90 degrees minus z plus x. This tells us that theta equal to H. So this angle H can be replaced with theta. Now look at this triangle CDP. We have two of its angles, that is this and this, to be congruent, meaning the triangle is an isosceles triangle. The sides facing the congruent angle are also congruent, which are this and this side here. So since the length of this side is n, this must also be n. Still on triangle CDP, we draw its median. The median bisects the side it touches, that is this side. So this part and this part are congruent. Let's assume their length to be. Still on the median, we know if the median of an isosceles triangle is drawn to its base, the median is perpendicular to the base. So this angle here is a right angle. Now look at this line AD. We have its length here to be 30 centimeters, but it is divided here into three parts. This 24 centimeters, this z and this z. So 24 centimeters plus z equal to 30 centimeters. Z plus z is 2z. Subtract 24 centimeters from both sides. Here 24 centimeters minus 24 centimeters is 0, while here 30 centimeters minus 24 centimeters is 6 centimeters. So 2z equal to 6 centimeters. Divide both sides by 2. Here 2 cancels 2, while here 6 centimeters divided by 2 is 3 centimeters. So z equal to 3 centimeters. That is, the length of this side each is 3 centimeters. Let's label this point R. Now look at triangle ACR. It is a right angle triangle. Don't forget, this side AC, we have its length here to be 18 root 3 centimeters, and the length of this side is the sum of this 24 centimeters and this 3 centimeters. Since it is a right angle triangle, we can use the Pythagorean theorem to find the length of this side. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So using the Pythagorean theorem, it's root 3 centimeters all squared equal to 24 centimeters plus 3 centimeters all squared plus line CR squared. 24 centimeters plus 3 centimeters is 27 centimeters. 27 centimeters all squared is 729 centimeters squared. Here 18 root 3 centimeters all squared is 18 squared times root 3 squared times centimeters squared. 18 squared is 324. Root 3 squared is 3. 324 times 3 times centimeters squared is 972. So 972 centimeters squared equal to 721 centimeters squared plus line CR squared. Bring 729 centimeters squared to the left hand side of the equation. So 972 centimeters squared minus 729 centimeters squared equal to line CR squared. 972 centimeters squared minus 729 centimeters squared is 243 centimeters squared. So 243 centimeters squared equal to line CR squared. 243 centimeters squared is the same as 240 centimeters squared plus 3 centimeters squared. 240 centimeters squared is also the same as 24 times 10 centimeters squared. 24 is thrice 8, so it is 3 times 8. This 8 times this 10 centimeters is 80 centimeters. Now from 3 times 80 centimeters squared plus 3 centimeters squared, we can factor out 3. So it will be 3 open bracket 80 centimeters squared plus 1 centimeter squared. 80 centimeters squared plus 1 centimeter squared is 81 centimeters squared. So 3 open bracket 81 centimeters squared equal to line CR all squared. Taking the square root of both sides, here square root of line CR squared is line CR, while here square root of 3 open bracket 81 centimeters squared equal to root 3 times square root of 81 centimeters squared. Square root of 81 centimeters squared is 9 centimeters. Root 3 times 9 centimeters is 9 root 3 centimeters. So line CR equal to 9 root 3 centimeters. That is, the length of this line CR is 9 root 3 centimeters. Now from this triangle, since it is also a right angle triangle, we can also use the Pythagorean theorem to find the length of this side n. It is the hypotenuse because it is the side facing the right angle. So using the Pythagorean theorem, the square of this n must be equal to the sum of the square of this 3 centimeters and the square of this 9 root 3 centimeters. So n squared equal to 3 centimeters all squared plus 9 root 3 centimeters all squared. 3 centimeters all squared is 9 centimeters squared. Here 9 root 3 centimeters all squared is 9 squared times root 3 squared times centimeter squared. From 9 centimeters squared plus 9 squared times root 3 squared times centimeter squared, we can factor out 9 centimeters squared. So it is 9 centimeters squared open bracket 1 plus 9 times root 3 squared. Root 3 squared is 3. 9 times 3 is 27. 1 plus 27 is 28. And 28 is 7 times 4. Bring 4 out of the brackets. 9 centimeters squared times 4 is 36 centimeters squared. So n equal to 36 centimeters squared. Take the square root of both sides. Here square root of n squared is n, while here square root of 36 centimeters squared open bracket 7 is square root of 36 centimeters squared times root 7. Square root of 36 centimeters squared is 6 centimeters. 6 centimeters times root 7 is 6 root 7 centimeters. So n equal to 6 root 7 centimeters. That is, the length of this side n is 6 root 7 centimeters. Now line CD we know is a chord. The formula for calculating the length of a chord is 2r sine 1 over 2c. So 6 root 7 centimeters equal to 2r sine 1 over 2c. 6 is the same as 3 times 2. This 2 cancels this 2. C is the angle called CD subtend to the center. We don't have it here, but we can see this angle x is subtended by arc CD to the circumference. The angle at the center we know is twice the angle at the circumference. So since C is the angle at the center and this x is at the circumference, C will be equal to 2x. Substituting here, 3 root 7 centimeters equal to r sine 1 over 2 open bracket 2x. 1 over 2 open bracket 2x is x. But what is sine x? Look at this triangle ACR. Since it is a right angle triangle, we can use a circle tool. Taking this angle as theta, this is the opposite and this is the hypotenuse. So theta equal to x, opposite equal to 9 root 3 centimeters and hypotenuse equal to 18 root 3 centimeters. From here, sin theta equal to opposite over hypotenuse. Theta is x, opposite is 9 root 3 centimeters and hypotenuse is 18 root 3 centimeters. So sin x equal to 9 root 3 centimeters all over 18 root 3 centimeters. Here centimeters cancels centimeters and root 3 also cancels root 3. This 18 is 9 times 2. This 9 divided by this 9 is 1. So sin x equal to 1 over 2. Substitute here, 3 root 7 centimeters equal to r times 1 over 2. R times 1 over 2 is 1 over 2r. Multiply both sides by 2. Here 3 root 7 centimeters times 2 is 6 root 7 centimeters. While here 1 over 2r times 2 is r. So r equal to 6 root 7 centimeters. And the formula for calculating the area of a circle is pi r squared. R is the radius, which we have here to be 6 root 7 centimeters. Substitute here, area of circle equal to pi times open bracket 6 root 7 centimeters all squared. 6 root 7 centimeters all squared is 6 squared times root 7 squared times centimeters squared. 6 squared is 36. Root 7 squared is 7. This pi is 22 over 7. This 7 cancels this 7. 22 times 36 times centimeter squared is 792 centimeters squared. So the area of the circle which I asked to calculate is 792 centimeters squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.